Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at your mathematics. As you can see over there, Surds is what we'll be starting with in today's lesson. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively important, ladies and gentlemen. A day without learning something new, it's a day wasted. By so saying, please, Rosie, please, Toby, please do make sure that at the end of each and every lesson that I conduct, you learn something new. So, guys, a very warm welcome to our new learners. So, without any waste of time, we will be continuing from where we left off yesterday. So, just in case if you missed the two lessons that I've already done, I've sent the links in the group. You can just click on those links to catch up. But for now, we continue. So, Surds is what we'll be looking at. Most importantly, make sure that you've got your mics muted. You will only unmute when requested. For the last time, anyone just to confirm if you can see, if you can clearly hear me, and also whatever that I'm writing there, is it clear? Just to confirm.
Yes, I can see low 1, low 2.
Sir.
Okay. Under Surds, Bantu Bakit, the moment you hear the word Surds, always think of square root. So we've got only two laws for now that we'll be looking at, which is the multiplication law being law number 1 and the division law being law number 2. Just like I've done with the laws of exponents. In today's lesson, we are not looking at the laws of exponents, but the laws under Surds, which is only two simple laws. Okay, so here they say if you are having n, then you have square root of a being inside the square root, and this is being multiplied by n square root of. Look at this. Now we are having b and not a. The law says Bantu Bagiti, because I'm not really sure of what to call this, but because that, for now, let me say the tail. So every time when I talk about the tail, I'm talking about this thing in that position. I'll find a proper way, but for now, let's just call it a tail. When we look at the tails of these two squares, can you see they are the same? Okay, because they are the same, that means we can just represent them by just one tail over there and say square root of. Then you multiply whatever that is inside the bracket, meaning we are going to have A multiplied by B. I'm just not sure if this makes sense, but I'm just going to try any example. Let's say, for example, we are having, my name is Desmond, I will use letter D, square root of, maybe let's use a number and say 4, multiplied by, my name is Desmond, I'll use letter D, square root of 2. According to this law, you therefore ask yourself a question, are the tails the same? If an answer to that question is yes, can you see it's D? So that means you can just write 1D representing both tails having the square roots. Then you just multiply whatever that is inside, before multiplied by 2. So it's more like is D square root of what is that by that? It is equals to 8. Before I go deeper, are you sure I'm not confusing you guys with what I'm explaining there? Are you guys sure that you fully understand?
Yes, sir. Yes, I understood.
Yes, sir, I understood.
Okay, 100%. So let me maybe bring another example. Tobe, remember to mute your mic, honorable member. There should be a button on your screen where you can
Hello?
click to mute your mic. She
Hello?
has muted her mic. Zain Yebo.
No, I just want to check, man. If the tail is always the same, it's always the case with the tails, always the same.
Yes. So the law says if the tail is the same, then you multiply whatever that is inside.
Okay, that's fine.
Remember, Zain, never say the tail in class. No one knows about the tail. It's just for our lessons to make it easy to remember. Nay. So everyone, never talk about the tail in your class. Everyone is going to laugh at you. But just know in your heart that this is the tail for the sake of us explaining. Okay, maybe let's say we are having Z for Zain, square root of 2 multiplied by D, square root of 2. Mr. Zain, this is a question that I'm going to ask myself. Are the tails the same? No. If not, then I cannot. Can you see? I don't even know what I can do to apply that, because it is not applicable. Meaning, you cannot somehow seeing yourself multiplying 2 by 2. Why? Because the tails are not the same, and you cannot write ZD, because with you doing that, it's more like you are multiplying the tails. I hope that makes sense, honorable members. So, with regards to the law of multiplication under Surds, it is as simple as that. Trust me, it is as simple as that, but a bit complicated in exam questions. So it is a bit complicated because examiner tries to actually combine all different laws that you need to apply. The tricky part is you not knowing where to start, which is something that I'm going to be training you as we continue with our lessons. Very, very much important, ladies and gentlemen, that you never miss any of my upcoming lessons. Okay, for now, let's just leave it there and maybe try have a look at law number 2. Obviously, division. We've just done 1 for multiplication. There is the multiplication. Before I forget, Tobe, please do allow me to explain something. Multiplication can be written or represented in multiple ways. For example, you guys know this sign to be multiplication. Again, another way of representing multiplication is by brackets. Another way is by the dot. And the last way is just having nothing. Let me quickly give examples. When you multiply the numbers, listen very carefully. When you multiply the numbers, you use that multiplication of times or that cross. Then, when you are multiplying a number and a letter, for example, 2y, that's when you use nothing. Can you see? Between 2 and y, there is nothing. That nothing in your mind, you should remember that. This is actually 2 multiplied by y and not just 2y. Okay, maybe when it comes to the brackets you can use with multiplying whatever and whatever. But in most cases, brackets are used in that case where, for example, you've got that, and then in between, maybe you can have a y, maybe a sign, and then you have another letter. This is normally how we use the brackets. It's not advisable to use multiplication. It's not advisable to use nothing, because otherwise, if you use multiplication, it's like you're having 2 times y, then plus z. So it's always best to use brackets in this case. What about a dot? Where do you use dot? Use a dot if you're multiplying a letter and a letter. For example, A times B. So that dot, it means A dot B. Why can't you use a dot when you're multiplying the numbers? It's because it ends up looking as if it's 7, 2. Whereas in your mind, you might be trying to say 7 times 2. So just understand how a multiplication can be represented. As we continue, I'm going to be explaining a lot more of this. For now, you might not understand why I had to explain that, but as we go deeper, you will realize that it is very much important for you to be aware of that. Sometimes it is taken for granted that you understand or you know, and it's not well explained. So in our lessons, we try by all means, what do they say? To leave no stone unturned. Yes. Okay. So now, law number 2 of division. What does the law say? Maybe let's stick to letter N over. To keep it simple, let's use letter A inside the square root and say over. Again, our tail being N. Square root inside having B. I'm pretty much sure that based on what we have done here, Zane can easily notice that there's nothing tricky there. You can see the tail, it is the same, so we just represent it as just one tail, and then because it is the law of division, it means you divide whatever that is inside, meaning we are having A over a B. Let me maybe give an example using the numbers so that it sinks. Let's say, for example, we are having 4 square root of y over no. Let me remove that and say y over 4 square root of b. So that means, is the tail the same? Yes, the tails are the same. You can just represent it by one tail, and then you divide whatever that is inside the brackets, being y over b. I'm just not sure if libandla lakaNkulunkulu liyazwisisa ukuthi kwenzakalani lapha. Are you guys understanding what I'm trying to explain there?
So what if the tails were not the same?
If the tails were not the same, it means we cannot apply the law. We just leave it as it is.
Okay, so can I please ask a question?
Yebu.
So if, let's say, the tail at the top, Moria division is N, and then...
Who's speaking? Okay. Remember, guys, most of you guys are new. I only remember learners from last year. So just make sure that if you're speaking for the first time, mention your name and then continue. Okay, let's say
So if we have like the tail at the top and then the second one at the bottom does not have a tail, how do we solve that?
A very, 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 very good question. A very, very, very good question. Let me not forget to mention that, Bantu Bakit, the benefits of master classes It's in such cases where someone thinks of something, they ask it, and I remember that I need to explain this to you guys. Lesedi, I want you to repeat that. Let's say, for example, we have 3 square root of maybe x. What did you say about the one at the bottom?
Sir, maybe it's like 3 square root of x divided by square root of y, but it does not
You,
have
the tail.
the tail. Yes.
That's what I wanted you to say, Lesedi. Notice something. Lesedi mentioned that, let's say this one, it does not have the tail. But guess what? The tail is there. Anyone who knows what the tail is?
Yes,
It's
sir.
true.
Is it
It's
an
true.
invisible one?
Yes, I
That's
expected
one.
someone to make a guess and say an invisible one. But in this case, the tail is always invisible too. Um, if you've been attending my lesson since last year, and you already know this, I'll just make an assumption that you did not say a thing. So, Bantu Bagit, always, Mr. Zain, always, when you have square root of 4, just know that there is always an invisible 2 over there. Meaning, in this case, in Lesedi's case, that means you cannot apply the law. Why? Because the tails are not the same. What is the tail of that of the numerator? The tail is 3. What is the tail for that? The tail is an invisible positive 2. Lesedi, waitola manje.
Yes, sir. Yeah, I understand.
Okay. Also, let me explain something to you guys. But before I do that, let's maybe run a test. If you've got a scientific calculator, punch this on your calculator. Wait, let me think of something that I want you guys to punch. Okay, maybe let's just run it. Let's punch this thing on a calculator. I think it has to give us 2. Let's punch that and also punch that and check if it also gives 2. I'll quickly check also on my side. But be careful not to punch 2 square root of 4. Be careful not to punch that. Let's see. You start by shift, and then there's that button on the, no, yes, shift. Then there's that button there. I just don't think you guys will be able to see. You press shift, that button there, that has x to the power of that thing there. Let's see. At the top, using your arrow, you say 2, and then inside you say 4. Yes, it gives. Guys, are you following, or am I losing you guys?
We're following.
No, I'm still with.
So, Esitle, this is what we are trying to do. We are trying to check or test or prove if indeed this 2, it is actually there. So we firstly punch that having a 2 there to check if it gives us 2. Then we also punch without having an actual 2 there to check if it also gives us 2. It does give us 2 in both cases, meaning there is always an invisible power of 2. So now, Lesedi, let me now be practical. I hope you guys will be glad to understand this. The reason why, let's say, I'll need to think of an example. Let's say you have square root of x. It's equals to maybe 2. Yes, maybe 2. Yeah, let me keep it simple. Can someone tell me, how do we remove square root if we want to solve for x? Just give it
We
a
raise
check.
Teacher, do
it
you know
to the
square?
power of an inverse. So if it's the square root of, we'd raise it to the power of 2, for example.
Yes, yes. So this is what you're saying. Nay, we multiply both sides by 2, isn't it?
Yes, sir, that's what I'm saying.
Yes. So what I want to do is to explain the reason behind that 2. I want to explain why you always remove a square root by 2. It is because I'm going to explain this also, Zain. They say if you are having a square root of y, for example, this is actually the same as you have that invisible 2 there. At the power of y, you have invisible 1. So it is actually y to the power of that invisible 1 over that invisible 2 there. So what I'm saying is that here it's more like you are having x to the power of invisible 1 over invisible tail being 2 squared, and then obviously that it gives you a 4, for example. So esihle, the reason why you remove a square root by 2 is because they know that this 2 cancels with that invisible 2 from the tail. Then you end up having a x to the power of invisible 1, which is equals to 4. I'm not sure if it makes sense, Bantu Bakiti. What I just wanted to explain is for you to understand why we always remove a square root by 2. Does it make sense? Do you now understand why you remove a square root by power of 2?
Yes, sir, it makes sense.
Okay. So now what I'm going to do is to remove all of that. But before I continue, do you guys understand that law number 2 for division? Anyone who's got additional question before I continue? No further question?
Sir.
It seems like we are all on the same page on that one. Okay, so I'm now going to remove all of these. Then we try to work out some few examples. Remember, guys, this is just a warm-up. We haven't started. Actually, we did, but we haven't started. Okay, so let's just try to work out some quick examples. Let's say, for example, I'm just trying to think of which example to. Okay, maybe let's say we are having a square root of 2 multiplying square root of 3. For the sake of time, let me not ask you guys how you work it out. But what you can do without having to explain or share your thought, you can just quickly try to work it out from your side, as I'll also be working it out. Only ask if you don't understand, but I'll make sure that it makes perfect sense. Okay, Mr. Zain, here comes a question. I notice I've got a square root, meaning I'm dealing with Surds. Okay, which law am I going to apply between law 1 and law 2? It seems like this is the relevant law to be applied. Okay, now that I notice I'm going to use law number n, here comes the question. Are the tails the same? A tengsua, because you are having an invisible that and invisible that, meaning I'm having invisible 2 square root of, then I can multiply whatever that is inside. That means this is that times that. What is that times that? That is 6. Makes sense, Bantu Bakiti.
Yes, sir.
Okay, so now let's try this one. The same process. Surds, law number one, the tails, they are the same. Okay, now that the tails, they are the same, that means I can just represent those tails by just having one square root, invisible 2, then I'm having 3 multiplied by 3. What is 3 multiplied by 3? It is 9. So this one, you can further work it out. I think it's a perfect square. If you say square root of 9, what does it give you? I think it gives you 3. That means this one, it ends there. But this one, you cannot further work it out because maybe when you say square root of 6 on your calculator, it just remains as square root of 6. That's why you leave it there. But this one, you further work it out. Bantu bakithi, does it make sense?
Yes, it makes sense.
It does.
Okay. Now, let's go deeper. Okay, so now let's maybe have a look at something similar to this. I'm pretty much sure that it looks a bit confusing. Maybe let me talk to Zain. Zain, are you still there? It seems like Zain he's not there. Okay, it's fine. I wanted to say on your behalf, let's say it looks a bit confusing, but this is what you need to know. Let's have a look. Remember, guys, at all the times, a power of something, it means something. So if you are having whatever to the power of 4, that means you are having 4 of whatevers, meaning you are having that. If you are having x to the power of, let's say, 3, that means you are actually having x times x times x. If it was to the power of 5, then it means it's times x times x. Okay. That means here in this case, can you see I'm having whatever there? That means I'm actually having whatever and another whatever. That's what I was trying to explain regarding that. Kuli, you remember I just explained 3 types of multiplications: that, a dot, or 4, and also nothing. So that means brackets are the same as multiplication. So I now need to rewrite this thing in a familiar manner, meaning this thing is actually the same as square root of 4 dot square root of 4. It is the same thing. It is also the same as a square root of 4 times square root of 4. It makes no difference because at the end of the day, they are multiplying each other. Can you now see? You can easily work out that, but it was a bit confusing when it was given in that manner. So this is what, for example, they will teach you in class, but in exam, it comes as that. And your teacher will say, you just apply the same law. And by that time, it's too late. So that is why it is very much important that we leave no stone unturned. So can you see? Tails the same? Yes. If the tails are the same, you can just represent it as just a tail square root. Then you're having 4 times 4. What is 4 times 4? I think it's 16. Is it 16? Thanks, Sua. Is 16 a perfect square? You will know by by punching it there. Square root. Yes, square root of 16 is a 4. Then that means this is how it ends. Someone might be wondering.
So can I ask?
Yebo.
So, sir, like how, because I tried it before, you could solve it, ne? And
Hmm.
would it be correct, or would you lose some marks if Akiri, the the third and the four are in brackets and then it's squared. So if you
Hmm.
just said the squared, the squared minus the third, like I mean the squared cancels out the third, and then your answer is just four automatically. Would you lose some marks? Must you show all the steps?
You wouldn't if you either show all those steps, or otherwise if you just say 4 to the power of that, you're having 2, and then you show it as it cancels in that manner, then you say 4. But kuli in this case, remember, we are trying to apply those laws. That is why we wouldn't take that shortcut, but instead try to follow that process where we apply those laws. Can you see?
Oh, yes, sir.
Yeah, so it is for that reason that we are just trying to make sure that we abide by the laws. We want to be, what is it? Law abiding citizens. Yes. Let's try to be the law abiding citizens. But this is correct, but it's a shortcut. And also, it's something that you would use in real life. I mean, in exam, this is what you can use. But otherwise, for now, for the sake of applying the laws, then we just stick to that lengthy process. So now, let's maybe try to have a look at a different question. Maybe this time around, the one that requires that division. Let's see. Let's say we are having 3 square root of 16 over 3 square root of 2. This one I'm going to do it also. So division law number 2, and then the tails are the same. That means I can just have one tail. Then I have 16 over 2, which is equals to, then I work out whatever there is inside. What is 16 divided by 2? I think it's 8. I think it's 8. I think it's 8, yes. Yes, I think it's 8. Okay. So now, this is where you might need to expand. And this is where it gets a bit tricky. I'm just hoping that what I'm going to explain now is going to make perfect sense. Okay. Remember, guys, I just explained that when you are having that there, you can still represent this thing as what you are having inside the square root to the power of 1 over 3. I'm pretty much sure that if you punch this on a calculator, it is then going to give you a final answer. Otherwise, if you get to this stage where you have worked out whatever that was either multiplying or dividing inside the square root, then you are welcome to punch all of that and give a final answer. What are you guys getting as your final answer?
2.
Is it everyone who's getting 2?
Yes, it's 2.
Yes, sir.
Okay. So what I'm, hey, is it you, the Chumis? Did I hear your voice? Let me see. Chumi. Okay. So now let's try something different. I think it's also easy, this one. Let's go for square root of 27 over square root of 3. Same. What is it? The tail the same, then you are having that over that. What is that divided by that? Let's quickly see. 27 divided by 3 is 9. So that means you're having square root of 9. Then you can punch this on a calculator and it's going to give you 3. I hope that makes sense. So it is as easy as that. For now, let's try to do some more examples. I'm just not sure whether to say some more of complicated stuff or because they are easy, but it's now becoming a combo. Let's give it a try. Let's say, for example, you are given 5 square root of 3 plus 2 square root of 3 minus 3 square root of 3. Just with a yes or no and maybe. Do you think you can easily work this out based on the laws that I've explained? Yes, no, maybe.
Yes.
Maybe.
Last one.
Maybe.
Yes.
Maybe. Yes.
Hey, that last yes. You know that one learner in class who's sitting there in the corner there, and he just lowers his head and under the table he says yes. That's what I heard. But don't worry, I won't say give it a try. I'll just quickly explain that. For the maybes and the no's, think of this as the following. You are having a coefficient, a coefficient, a coefficient. Can you see? This is the same. So this thing, it's more like you are having 5x plus 2x minus 3x. I hope now you are having some light. So it's more like you are having a 5 bananas, 2 bananas, you subtract 3 bananas. What are you having there? So let's see. 5 plus 2, obviously it's 7 minus 3. It is what is it? 4. So it's more like you are actually having 4x. So now let's work out that one and check how it looks like. So it's more like you're having 5 square root of 3 plus that square root of 3, which is 7. So it's like you're having 7 square root of 3, just like there you had what is it, 7 x. Then minus 3 square root of 3. So that means this is the same as 7 minus 3. What is that? That is 4 square root of 3. That's how it ends. If you want to know if this answer is wrong or correct, punch all of that. I'm telling you, it is going to give you that. So mathematically, you don't punch that, but you show all the steps to accumulate all the marks allocated to that specific question. Does it make sense, guys?
Yes,
So
it
how did
does.
you get the 7 square root of 3?
How did I get 7 square root of 3? It's 5 plus 7. 5
Yes,
bananas. Yes. Can you see now?
yes, sir.
Okay. Let's maybe quickly try this one. I just want to make sure that I'm not taking any shortcuts and skip some problems that to me are easy. Square root of 7 plus 2 square root of 7 minus 6 square root of 7. So let me work out that one. To me, it's like an invisible one there, plus 2 that minus 6 that. The first thing to check, try to check if the square root, whatever inside, is the same. If it's the same, it's more like you're having a 1 square root plus a 2 square root. What is that? Is it not 3 square root? Can you see? Whatever that is inside, minus that. So it's like the like terms. This thing is like just 1y plus 2y minus 6y. Let's see. What else? are we going to do? So you say 3 minus 6. What is that? Is it not negative 3 square root of 7? Try quickly punch all of that and check if it gives you that.
It seems like I'm missing something now. You not say that the square root have an invisible 2.
Oh, okay. So remember, in this case, Luvuyo, we have two different things. Let's say we have the tail and then we have maybe P. So it is the tail when it is written like that. But when it is written like that, can you see the difference? So this is the tail, but this one, it is not the tail, it is the coefficient. The tail is that invisible 2 there. But in this case, you cannot apply that law. Why? It is because you are having this as a term. In between, you are having a sign of a plus or a minus. And then you are having that sign, and then you are having a that. Maybe let me further expand my explanation, Luvuyo. So it's more like, can you see it's an invisible 1 there? This thing is like it's 1, tail of 2, square root of 7, plus 2, tail of 2, 7, minus 6. Let me even do the times there. 6 times, what is it? Tail of 2, square root of 7. So can you see that the tail and the square root of something inside, they are exactly the same. So this thing is the same as maybe 1 L for Luvuyo plus 2 L for Luvuyo minus 6 L for Luvuyo. So it's 1 plus that, it gives you 3. 3 minus that, it gives you negative 3 L for Luvuyo. I'm just not sure, Luvuyo, if that makes sense. So the reason why you cannot apply those laws is because these laws, they don't have a sign of a plus or a minus. But in this case, you are given the signs in between. So it's more like you separately check if you need to apply the law there. You don't need to apply any law. Also there, you don't need to apply any law. Also there. That is why you just follow Potmas and say that plus that, minus that. Maybe to make some sense, Luvuyo, and for the sake of everyone else, let me do this. Let's say, for example, you were given the square, let's say 2, the square root of 4. I'm just trying to think of something here, times, not even 2, but let's say 3 to be practical, times 3, the square root of 2. Yes, this is going to be perfect, Luvuyo. And then they say square root, let's say 3 square root of a 8. I want to be practical. 8. Luvuyo, are you still there?
Yes, I'm still here.
Okay, so when you have a look at this, you will realize that here you can actually apply the law of multiplication, but here you cannot apply, because this thing, it's more like it's already simplified, but this one you can simplify it. How do you do that? You ask yourself the question, are the tails the same? Yes, the tails are the same. Okay, in that case, that means you can represent that with 1 tail, and you are having 4 that you multiply by 2. Then you still have plus this one. You cannot work it out because it is just as it is. You cannot further work it out. So now here you need to continue. You are having that 3 as the tail. Then what is this? This is 8 plus you are having that as it is. So can you now see you are having the same thing? Therefore, remember, there is an invisible one there, there is an invisible one there, meaning you actually have two of those same things. That is why you're going to say you have 2 the tail square root of 8. And in some instances, you might remember this thing, Luvuyu, it's not just 2, the tail, and whatever. This 2 is the coefficient that multiplies the whole of that. If 3 square root of 8, when you punch it on your calculator, if it gives you 2, that means you can further work out this thing to be 2 multiplied by whatever that this gives you. Let's say it is 2. Then that means the final answer to this question is 2 times 2, which is equals to 4. I'm busy praying that you guys are not being confused by what I'm doing there. Luvuyo, are you sure I didn't lose you on that one? Bantu Bagit, are we still together?
Can you re-explain the 2.3? 2 times 3 to the square root of 8, that part.
This one?
No, the third one at the bottom. Yeah, after that one.
This one?
Yeah.
Okay. So, it's more like, it's more like, you are having 2 being that 2. Let's say for some reason this wasn't that, but let's say it was that invisible 2 and then square root of 4. So the question is, if you punch this on a calculator, what does it give you? It gives you 2. So that means you end up having 2 multiplied by 2. So now try to punch this one and check what it gives you. I think we have done something similar to that, and we said that it gives us, was it 2? Let me quickly check just to be sure. That's why I was saying whatever that it gives you, because 8 to the exponent 1 over 3. Yes, it's 2. So that is why I'm having 2 there, which is multiplying with that 2. So that means when you punch all of this on your calculator, even though it's a problem that came out of my mind, does it give you 4 when you punch all of that? Can Samaria Wahawelo give us a quick answer there? When you punch that, does it give you 4?
Yes.
Yes. So, remember, guys, these are just the basics that you should be aware of. When it gets to exam, they won't give you something similar to. You might be lucky to be given something similar to that, but it gets a bit more complicated. But trust me, these are the most complicated questions that you will have as compared to what you'll be given in exam, because they're just a straightforward type of questions. I think for now, we might need to conclude on this part regarding Surds and try to have a look at some questions from exam question papers and see if we can try to start with what we started with beginning of our lessons. I'm just trying to think, but I think you guys did notice that compilation of question papers that I sent. Did you guys notice that? I tried to highlight it in the group to say this is what we'll be looking at in today's lesson. Did you guys see that?
Yes,
Do you know what I'm talking about, Moose?
Yes, sir.
Okay. Any questions regarding this before we move on? It's not our last time doing this. We will come across questions related to this. I will still remind you in case if you happen to forget, because what happens in maths is that just like you understood everything there, you tend to forget in case if you don't give yourself enough time to practice these problems. What I'm going to do, just like I did, I'll take a screenshot of some examples that you can work out and practice on your own. Only if you've got a problem during the next lesson, that's when you can ask the challenges that you came across. Most importantly, guys, I think I'll need to mention these before I forget. I pray that some parents are listening so that they've got an idea of what happens behind the scene. Okay, most importantly, guys, we do not help you with homeworks, assignments, or whatever. The reason to that is because in the past years, I've noticed that a learner says, I've got a homework, assignment, or whatever, and we assist them. Then they get 100%. After getting 100%, their teacher thinks or assume that they fully understand the homework was easy, the assignment was easy, whatever was easy. Then the teacher tend to move on to something else. Whereas this is not your 100%. You did not fully apply your mind. I've realized that it's actually best for you to be given homework, assignment, and everything. Please, guys, don't ask help from your parents, your tutor, or whoever. You can strategically ask for help, especially in a case where you work out the homework and you say, can you just quickly check for any possible silly mistakes? In that way, if you give it to me, I'll just be checking for obvious mistakes. But for a serious mistake, I will just ignore it. Why? I want you to get 0% on your homework, assignment, or whatever, so that your teacher realizes that it is very much important that they emphasize whatever they taught you in class until you fully understand the homework, assignment, or whatever. If you do it yourself, and you improve from that 0, you get at least 50%. It is promising that during exam, if you are given a question which is an experiment based on a similar thing, you will confidently answer that question. But if you got 100%, then life goes on, you move on. Come exam, you get 0. So rather get 0 or your own marks with your homework, assignment, or a project, instead of you having to get 0 in exam. Because once you get 0 in exam, it's a fail, a complete fail, which means you need to repeat. But if you get it in your homework, assignment, project, you still have a chance. And also, homeworks, assignments are not for you to get total. They are meant for the teacher to check if you guys understood what they've explained to you. So it is the main reason why we completely do not help you guys with your homeworks, assignments, or projects. We want to teach you, we want to train you on how you answer exam type of questions. Trust me, this prepares you for your first year at varsity, because there I'm telling you guys, if you are used to having your assignments being done by someone else, there you will see flames. So just make sure that you get used to working things out by yourself and not relying on others. Do not copy, even if your friends get 100%. Do not worry, do not copy, just be honest to yourself. Lastly, I want to tell you guys that the reason why I got distinctions, I always say this, it is because in my school, I think it has over 30 years, the age of my school. The reason why I can say I was good in explaining to my peer or fellow learners is because I think no one has ever made mistakes more than I did in my school. So don't be that type that always seek to get 100% in your classwork, homework, or whatever. You get 100% and everything. For me, I used to get 3%, 4%, and I made sure that This is the 3% that comes from my mind. I did not ask help from anyone. When I practice by myself, I had to make sure that I do as many mistakes as possible. That is why, Kuli, when you ask me a question, I'm able to easily explain to you. The reason is because I've already done that mistake. I know all mistakes related to most of the questions. That is why when I explain, I also include possible mistakes or common mistakes. So I do those mistakes on your behalf so that you don't repeat them in your exam. Very, very much important, ladies and gentlemen, that at all the times you pay full attention to all the details. That was the first point that I wanted to indicate to you guys. Um, and I notice I forgot the second point, but we still have a whole year. I will remember to make that point. But otherwise, do you guys allow me to move on to the next part of our lesson? We are very much close to reaching the end of our lesson, but I need to quickly take you through this. Do you guys allow me to continue?
Yes, sir.
Yes, sir.
But what I explained regarding the homeworks,
Yes,
assignments, or
sir.
project, does it make sense to you guys?
Yes, sir.
Yes,
Please,
sir.
please make sure to be honest to yourself, and you will thank me later. Okay, so now I'm just going to quickly browse through some questions. And most importantly, since I've covered all that I wanted you guys to be aware of, starting from tomorrow, we now solve these questions. I don't think there's any presentation that I need to do. Okay, so this is how I do lessons, Bantu Bakit. For every new chapter that I start with, especially in this same group that you are all in, there are what I call master classes. Master classes only focuses on common chapters. Common chapters, for example, solve for X, it's available in all the grades. That's what I focus on. Analytical geometry, functions, and everything. It's common in all the grades, and that also includes number pattern to a limited extent. So in this same group that you are in, there are more links to specific classes. If you're in grade 10, you join that specific group. 11 and 12, you join that specific group. That is where, for example, in grade 10 and 11, there's no differentiation. So that means differentiation, because it's a specific chapter, will only focus on that in the grade 12 group. So that is how our lessons are structured. And everything, it is not meant to make your life difficult, but to accommodate everyone, because we try by all means to accommodate all the learners in the country. So that is why it's only private lessons during exams based on the package that you choose. I hope you guys won't run away by the end of this month and look for other teachers or other tutors. Anyway, I remember yesterday there were two questions that I did at 180 kilometers per hour, and someone said, can we please try to redo those at a moderate pace on the next lesson? Is that honorable member available in this lesson? I'm not sure if it was Voiswa or who was it? Who was it? Let me quickly check if that honorable member is here. I don't see them. But Hamisa, you know what I'm talking about? Do you remember what we're talking about? What we're doing yesterday? Do you remember? Do you guys know what I'm talking about?
Yesterday I couldn't attend, so I don't know what.
Oh yes, yes. Anyone who remember?
Was it the last question?
Exponents and the definitions of exponents.
Yes, it was this question and the other one. So because I've actually delivered what I wanted you guys to be aware of regarding that part for Surds, let me quickly do this one and then we'll be done for today. So just in case if you missed my yesterday's lesson, you will realize why it is important to catch up Hello, I come back. I'm just not sure if you guys are still there and if you can hear me. I'm pretty much sure that some of you guys did notice that it's load shedding on my side, but are you guys still there?
Yes, we're still here.
Still struggling.
Okay. So it's fine. We'll just try to work out something. So just in case, if for some reason I somehow leave a group, you are advised to remain in the group for a few minutes, just so that I get my things together, and that includes trying to reconnect with Wi-Fi and trying to get some external power for light. So this is the question that I'll try to work it out such that you guys understand based on the laws that we learned yesterday. So just in case if you missed a lesson yesterday, for you to be able to understand what I'm going to do here, you will need to firstly catch up. So that is why I record those lessons, so that I don't have to re-explain the same lesson again. So let's see. If you remember, there is that law where we can separate the exponents, meaning we are having 3 to the exponent m multiplied by the same base to the exponent 4 minus we are having 6 multiplied by, then we expand or we separate that. It's going to be 3 to the exponent m multiplied by 3, maybe let's say to the power of that one. At the bottom, you say 7 multiplied by 3 to the exponent m multiplied by 3 to the exponent 2. here comes the question. How did I know that I must do that? If you remember, I did explain that in most cases where you have a sign of a positive or a negative, you know very well that you're going to take out something as a common factor. That's how I knew that I need to take out or I need to expand those. So I did that because I knew I was going to take out something as common factor and cancel something from the top and the bottom. So it's best to expand. Try to see what can be done. If nothing can be done, you can still take them to their original state. Let's say, for example, you expand, but on your third step, you realize you shouldn't have expanded that. You can still take it back to its original stage. There is no harm in doing that. But now, why did I do all of that? If you can check, you have this, which is the same as that on the other side of the sign in between. So I'm going to take it out as a common factor. It's more like factorizing. So when you remove this thing from that, this is what remains, being 3 to the exponent 4, minus when you remove only that, which is that one, it's removed, you remain with 6, which is multiplying 3 to the exponent that one. Someone might be saying, what about those dots and whatever? You remember what I explained regarding the dots. If it's a dot, you can rewrite it nicely as a multiplication so that it doesn't look like it's 6, 3. That is the reason why. So here you are having 7, which is multiplying 3 to the exponent m, multiplying 3 to the exponent 2. Before I continue, Zozozo and everyone else, are you still there? Are you sure I'm not breaking because it's load shedding on my side?
No, there's no problem, sir. Everything's clear.
We can hardly hear you say they are just break up.
It's
No, I can't
breaking.
hear you.
Kumalo Busisiwe, it seems like she's struggling to hear me. The other honorable members, am I not breaking? Carol, can you clearly hear me that side?
We can hear
Yes,
you.
I
Bullet,
can hear.
I can hear you.
You are not breaking, you're clear.
okay.
We can
It
hear
could
you,
be
sir.
it could be that the network is a bit poor on a honorable member side. But just in case if it's breaking, I think this lesson is recording. Let me just quickly check because I went out. Yes, 1 hour, 8 minutes. The lesson is still recording. It will be posted and then you can catch up. So can you guys see? I've taken out that as a common factor. Why did I do that? It's because I knew it was going to cancel each other out. Remember, this is an exam question that was allocated 4 marks. So for this type of questions, you expect 4 marks. So can you see, now I've removed this thing having a letter. I'm now just having the numbers, which is what? Which is that 3 to the exponent 4 minus 6 times 3 over 7 times 3 to the exponent 2. But let's just work it out to save space. What is 3 to the exponent 4? Let's see. So now it's numbers. That's when you can pull out a question paper. You only apply the laws if you are dealing with letters. But the moment it's only numbers, you just punch. What is 3 to the exponent 4? Hey, 3 to the exponent, is it 64? No, it's 81. Yes, it's 81. Just make sure that you get the same. What is that times that? Let's see, 6 times 3 is 18. Okay. What is, obviously this one we know is 9, so it's more like it's 7 times 9, or otherwise 7 times square root of that, 3 square root of that. Let's see, 7 multiplied by 9, this is equals to 63. Okay, let's see, what is 81 minus 18? 81 minus 18 is equals to 63. So that means I'm having 63 divided by 63. This seems to be 1. So that means an answer to this question is 1. I'm not sure if you guys fully understood what I've done over there. Rosie, are you okay that side, honorable member? Rose
I
Matou.
understand, sir. Thank you.
Sorry,
Oh,
sir, can you
there's
please
Busisiwe.
one?
I
Busisiwe.
try to understand. Can we have this on recording so that I can go over it tomorrow? Because today I hardly hear you.
Yes. This lesson is being recorded. Can you see there, Busisiwe?
I do, sir. Thank you so much.
Okay. Lindiwe, are we on the same page there?
Yes, sir.
Okay. Good people, I think, seeing that it's load shedding on my side and possibly the other honorable members are also struggling to hear when I explain. I think the other question that I did, let me not include it in today's lesson, but make a promise that tomorrow we'll start with it and go through everything. This one will leave it there, but before I close out, is there someone who would like to ask a question in relation to that? Any question? I suppose no question. This is what I wanted to show you guys. Can you see this question, the second page from that template, that compilation that I sent you? Can you guys see that it gets complicated? I'm not sure if you got that part. I was saying, can you see how complicated it gets during exam? These are the Surds. You have a tail, a square root, inside you have something. You have a tail, inside you have something. These two things inside, they look almost the same, but trust me, they are not, because you are having a plus there, you are having a minus there. And this question is allocated 4 marks. So that means even though you attended a lesson where I was delivering an introduction, but if you miss lessons where I solve for this type of problems, you won't be well equipped. You won't be fully ready. Even if your parents ask you if you understood everything, understanding doesn't mean knowing. Understanding doesn't mean ready. You can only be ready and confident to tackle exam questions only if you made sure not to miss any of my lessons, and also for lessons missed, just like Busisiwe. She's going to make sure that she catches up this lesson so that she follows on upcoming lessons. So just make sure not to leave any stone unturned. Guys, I'm about to sign out. Anyone who's got a question before I sign out, or so far so good?
I will have questions for you tomorrow after watching
Pindi
the lesson, sir. Today I didn't hear anything at all.
Mimela ayanda mphahlele Pulelo za. Okay, that was Busisiwe. But otherwise, I do thank you very much for joining. My name is Desmond, and I'm out.